All right, so thanks, Kat, for agreeing to walk us through your recursive solution. We're going to look at, which one are we looking at first? I think you might be muted.
Yeah, sorry.
Nice.
I did it. It doesn't matter. I mean, I did it in, I have Python solutions and JavaScript solutions, so I can
Oh, wow.
do any of them.
You did it all. Let's see the palindrome in
Yeah,
Python.
I can kind of put both up.
That's cool.
So I did this, I kept from my original solution where I had something that I'd run, like a helper function, I'd run it through each time to just kind of clean it up, get rid of any characters that I don't want, and to return it as either an array or a list. And then the way I did it is I just created like a pointer to the start and end letters for the array at that point. And then if they were not the same, then I'd return false. If they were the same and it was already if it was already only 2 letters left in the array, then it would return true, and else it would go through one more time back put together as a string.
Very cool. So how do you feel like your Python solution compares with your JavaScript solution?
I'm still definitely more comfortable thinking in JavaScript. So I feel like it just comes easier for me at this point in JavaScript. I feel like for Python, I'm just Googling a lot because I'm usually thinking about the solution in JavaScript and trying to find like an equivalent in Python, which probably doesn't lead to the most elegant solutions. So I think this time around I actually did the Python first just to kind of try to retrain my brain a little bit. But I think they're pretty similar. Just here I had to use the regex import.
Mm-hmm.
So just getting used to that as well, that you have to do that in Python.
Yeah. Have you worked with regex much in the past?
Just for solving challenges. Yeah, I've especially in JavaScript, I'm pretty comfortable with it.
Okay. So again, don't mean to put you on the spot, but can you read those regexes, or did you just like get them from Stack Overflow and be like, oh yeah, this is what it does, and it seems like it's working as described?
No, so this one is like, if the little arrow, if the little caret is inside the brackets, it means to negate like everything, basically everything but what's inside the brackets. So here it's asking it to replace anything that's not an uppercase letter, a lowercase letter, or a digit.
Okay, very cool. Don't tell us too much though, because that's going to be the subject of the rest of today's lecture. So I don't want you to, steal all my thunder here. Very cool. So yeah, is there anything else that you want to, bring our attention to or showcase about your solution, or think about your experience you want to share?
Yeah, I just it was just fun, I guess. I don't know. I had to think about it completely different, because originally what I did was I did create arrays each time, but then I just reversed the array. And then if I put everything to lowercase and then just kind of set, if this array reversed is equal to the original string in an array, then it's a palindrome. So I just had to reframe my thinking a lot to come up with a recursive solution.
Okay. Yeah, sometimes you have to think kind of hard in order to build a recursive solution for a problem you've already solved differently, though sometimes the recursive solution is maybe a little more obvious. Like for the factorial challenge, I feel like recursion is just the most obvious way to solve that. It's hard for me to think of a different way to approach that problem, even though I'm sure you could do it just fine with a loop.
Yeah, that one in like 99 bottles, I thought was like a one that to me seemed a little bit more natural with recursion.
Yeah, can we see your factorial solution real quick?
Yeah, this is JavaScript, and then This is Python.
Yeah, that's real concise. Just a one-line solution. Wow, cool. Does anyone in the class have any questions for Kat about her solutions, about her approaches or whatever? Nobody? You're not dying with questions about your peers' code?
That's a beast. She's good.
It's good. I guess it speaks for itself. Andrew?
Can you show your Roman numeral one?
Yeah, absolutely. That one was the trickiest for sure. Now that that one took me a while. But I kind of, I used the solution that I think Ankur had demoed. And I tried to rewrite it that way as closely as I could, but using recursion. I think this is probably the like least intuitive solution to me, but I don't know.
For me, Roman numerals was the one where like the recursion thing actually helped the most, because my original Roman numerals code was like 30 lines of like repeated code. But my recursion one was only like 5 lines. And I was like kind of surprised like how it made me think of the problem in a much like cleaner fashion.
Very nice. It's always satisfying when you're able to, refactor something to be a little more concise.
My palindrome one was way worse though.
Yeah, for this one, I had a bug for a while. And so I kept running the code. And I guess just kind of seeing how many times it was running was it just seemed like so much effort that I was making it do with the recursive solution. But I mean, it could be doing that behind the scenes with the loop too. And I just don't realize it.
Let me ask a quick question in the class. This doesn't really have much to do with technology, but did everyone here know what a palindrome was before attempting these challenges?
Yep.
No.
Okay, it's totally cool if you don't. I just think it's interesting. I like thinking about the extent to which these programming challenges require prior knowledge. I feel like a lot of the times the people writing them will assume that the things you're asked to like reason about in the program are things that everybody should know about. But I think that's an assumption that's not always true. And like a common problem that I've seen in teaching is like half the class doesn't know what a palindrome is, or they don't know what an anagram is. And that's like kind of an assumption as a starting point in a lot of these challenges. So I just think it's interesting to know that not everyone has the same like prior knowledge when we're approaching these programming challenges. Thanks for sharing.
I thought I knew how to bowl.
Say again?
I never understood bowling.
I said I thought I knew how to bowl until I looked at the problem. Then I'm like, maybe I don't understand.
I mean, throwing the balls is easy. It's just the scoring that's complicated. I guess throwing the balls is hard if you want to be good at it. Anyways, does anyone else want to share some code with the class? A solution to last night's exercises, bonus points if you want to show off a binary search.
I'll show binary search.
Let's see it.
I got to bring it up here.
Yeah, can you share your screen?
Yeah. Let's see. Find it. Okay. Share screen. Let's see. So there it is. Can you see it?
Yeah, I can see it.
Right. It's the classic algorithm, I guess.
Can you scroll up just a few lines?
Scroll.
Yeah, we're starting at
Oh.
line 4. Yeah, I think we were missing just the first couple lines. Okay, cool. So do you want us to just talk us through your solution? Maybe
Yeah.
test it a few times?
All right. Well, you start at the left is at the beginning index. The right is at the end. So while the left is less than or equal to the right, go in this loop. So you get the middle by adding the left and the right, and then integer dividing it by 2. So if it's less than the target, your left now becomes the middle plus 1. So you're just looking at the right hand side, and then if it's greater than the target, then it's the opposite. The right hand side moves down to the middle minus 1.
Mhm.
And if neither of those are the case, then you found your target. So just return the middle. So yeah, I noticed your test cases had a mistake in both the Python and the JavaScript.
You
What
might
was
be
up with
right.
that?
Just
Um,
trying to keep you on your toes.
Yeah.
No, I'm sorry. I should apologize for that.
No, it's fine. It's fine. So, but I fixed it. So let's see. All right. So now they all work, and it's the same thing in JavaScript. Just
Yeah.
change up the syntax.
Pretty similar though.
Yeah. There you have it.
Amazing. Can we look at the spec file real quick? I just want to see
Yeah.
the arrays you're testing it on.
I just used the same ones you provided.
Yep. So, man, that super big array is still not all that big.
Yeah.
But I want us to think about the performance of this algorithm a little bit. So there's, what is that, like 8 items in that super big array. How many checks do we have to perform in order to find one item anywhere in that array using binary search?
It's it keeps halving it. So that's the logarithmic. So
Right. So yeah, the array's got 8 elements right now. In our first check, we'll cut it in half, and then we're only looking at 4-item array, and we cut that in half. So we've got our 2-item array, and then if it's in the array, the target is either the first or the second item of the 2 items we're left with.
yeah.
So another way to think about this is that we can double the size of our array, and it only adds one more check to our binary search algorithm. Whereas in contrast, with a linear search algorithm, if you add one item to your input array, that adds one more check to the process of searching through it. So it's definitely cool that you're able to like write this code and regurgitate a binary search algorithm. But I think it's also a really interesting algorithm to know about and be able to talk about it and compare it with a linear search. And also the fact that binary search exists is part of the value of a sorted list, of a sorted array. Because now you know that a sorted array can be searched faster because you can use binary search on it. Whereas an unsorted array, you'd have to use a linear search, and that's going to be much less efficient. Andrew?
Yes, the Python method index of, does it just perform a binary search?
I don't think so, because I don't think it assumes that the list is sorted. You can call index of on anything, or an unsorted list, I believe.
Okay.
So yeah, I'm not exactly sure, like in practice, where binary search comes into play. I want to say that like databases use that internally to search through your data a little bit faster, because they can like control the internal representation of your data, and it's likely sorted in a really sensible order. But I don't know that for sure.
Can I ask a question?
Please.
One thing that I ran into, and I might have just missed a really obvious solution to it, but I'm wondering, Max, like how you so if you had an array where you had to break up to look at the second half, did you find that you had to track the middle in like the previous middle index somehow to add to it when you were eventually finding the index? Does that question even make sense? So like if you had if let's say, you know, your middle number was 5 and then you're looking for something like 7, 8, or 9 is that second half that you're then, you know, looping through and looking at. Oh, I'm sorry, you didn't do it. Yours is not recursive, right?
No,
Oh, okay, never mind, sorry.
yeah. And this one, I mean, since this wasn't in our recursive requirement, it's pretty easy to do, you know, iteratively. Yeah, but I guess, yeah, I could see how you could do it recursively, right? You just cut the list in half, yeah, and then just run it again on your new half list.
Mhm.
I can see
Yeah,
that.
it's just a lot. Yours just looks so nice and clean, and mine is really long because I had to like add that stuff in. So sorry, I completely misread yours. I didn't realize you didn't do it recursively.
So the description for the exercise actually didn't insist you do it recursively, but this would be another good opportunity to do so if you wanted to. Did anyone else perform this recursively? Want to show off what that looks like?
I guess I could show mine.
Please.
One sec. So like Kat was saying, I did end up having to essentially add the other half of the list back to the final index. So I just did that again, len list, floor division 2. This part right here is a little bit of a cop out, but that's the only way I could get it to work. But yeah, basically just if it's in the middle, find it. Otherwise, binary search on the second half and then binary search on the first half.
Sorry, can you tell me again what's going on lines 5 and 6?
So yeah, I realized like that part's not really like strictly a part of binary search, but the issue that I was running into, like for example, the last test case here, when we're searching for 6, that doesn't exist in this array, it would get caught in this right here. So it would end up returning -1, and then it would like add a half of the list back to the index. So basically it would return, in this case, it would return 3. So I kind of like, I don't know, I probably like ran through the debugger like 100 times to see exactly what was happening. And then I kind of just like included this part to like catch it really quick. And then if not, this part's all very bog standard binary search.
Mm-hmm. So remember, I was just talking about how binary search is so much more efficient than a linear search because you're just cutting the array in half every time instead of checking every item.
This part right here is basically just a linear search. So yeah, that's why I said it's kind of a cop out, but I mean, at least this part is good.
Maybe if you keep the left and the right index as parameters, I think it would make it easier. And you would,
yeah, I didn't think of that at the time. I started like looking at like outside solutions and I was like, okay, yeah, I see how that would work. But yeah, I mean, I'll probably end up refactoring this a little bit just to like get rid of the cop out because that kind of defeats the point of binary search. But like, you know, I do like this part.
Yeah, that's most of it.
Yeah.
But for sure, the in operator by itself is going to do a linear search over the array, over the list. So especially if you're doing that recursively, like you're doing one linear search for every recursive call of your binary search.
Yeah.
A lot of searching going on, but it's cool. I like the effort. Thanks for showing it.
Mhm.
Hopefully that inspires you about some next steps you can take.
Absolutely. How do I like, okay, here we go.
Raphael, can I show mine?
Please.
All right.
Always appreciate having volunteers, so I don't have to just awkwardly call on people.
Can you guys see it?
I can see it.
Oh, just a second, sorry.
Sure.
So I had to change a lot because when I added more test cases, it didn't work. I had to do a lot of debugging because I was confused with the index and the number, which I had set it up here, which is min value 0, which is actually my index, but I ended up getting confused later on when I was using the helper function here. But it took me, I don't know, quite long to get through this, but I think it worked. But yeah,
it looks correct as far as I can see. And you said you ran the tests and they were passing. What was the hardest part of this for you to write?
I think it was getting me confused with the index and the value. Every time I did half, and then I had to move either left or the right, and then I think I would say the debugger helped because I used the debugger, and then I think it showed me all the values. Otherwise, it was hard for me because I kept getting confused when I was like at 2, which meant like number. It wasn't like value 2; it was like index 2. So I got confused a lot, and it took a whole lot of my time. But I don't know, and basically here when I made like the helper function. So this technically, I think Ankur had done it. I only tried it after watching a couple of YouTube videos. So this is not me. I was basically trying if it worked. I had to change another thing, which was here I wanted to make it more generic so that we could use it later. So I didn't want to use the 0 and then whatever the length of the array -1. So I just kept it more generic here, but I don't know if that is appropriate for this. Yeah.
It looks like it makes sense to me. Like that top function binary search, that just gets called once at the start, and then it's your helper function that's actually called recursively. So yeah, if the first time you start calling your binary search helper, you want to start at the beginning of the array to the end of the array. You haven't ruled anything out yet. So I think it makes sense. You just hard code min value to 0, max value to the length of the array. One thing that you probably shouldn't need though is the array.sort at the top, It's just one of the premises of binary search is that the input array needs to be sorted. Otherwise, you just can't do a binary search on it. So you should expect that the inputs will be sorted to begin with. I think we might have mistakenly put one of the inputs out of order in the test cases.
So if we, so they usually give us like a sorted list. Oh,
Right.
got it. Because I tried keeping some test cases here because I wasn't getting, like, all my test cases were failing when I added. And then I put that in again. Okay, all right, that makes sense. Thank you.
Yeah, you're welcome. So you said it was a little bit tricky for you trying to keep track the index versus the value. So I agree that can be one of the things that's hard about these kinds of algorithmic challenges, just getting tripped up over that. Do you think this would be easier if instead of a list of string, or if instead of a list of numbers, it was a list of strings? Like if you were alphabetizing a phone book, or I'm sorry, trying to like find a name in an alphabetized phone book.
Is that a question for me?
Yeah, like if we change the challenge, do you think that would be easier for you to think about?
I don't know. I think the concept is the same. I think if you understand, you know, that you have to start from the minimum, whatever value to maximum. I think the concept is still same, like you divide it and you always either move left or right. I don't know. But I think with the numbers, definitely like the index, like you start with 0, that gets confusing. But for alphabets, I mean, for strings, it would be much easier, I think. Yeah.
Yeah. Just think as you're learning and debugging, the strings are maybe a little bit easier to see and understand. Jesse?
Yeah, just real quick on top of the what you were just explaining about the phone book thing. I know the CS 101 that you or 100 that you had us look at on our pre-work. I think it was like the second second class that you had talked a lot, went into that, and I thought if got a chance, if you wanted to understand the concept better, I think that was a really good takeaway.
Okay.
On top of that.
Yeah, thanks. Maybe we should all review that.
Can I stop sharing?
Yeah.
Thank you.
All right, does anyone else have any exercise solutions that they want to share, or have we seen enough student code this morning? No more brave souls? All right, so instead, Joe, we talked about doing some collaborative debugging. Do you want to get your broken code up on the screen? We can work on it together.
Sure. The code itself, John and I were working on it while we were looking at code, or he was working on it. He said it's working, it just doesn't work on my terminal for some odd reason.
Works on his terminal, but not yours.
Yeah.
That's an even better kind of bug.
Okay. Sure, 1 second.
That's the classic developer excuse. You know, someone says there's a bug in your code and they say, well, it works on my machine. So it's someone else's problem. I mean, that's not true. It's still your problem. Your code needs to work on everyone's machine, but it is something people say often enough.
So. Let's open everything up now.
You should be able to just open the whole folder in VS Code. And then you get everything in the hierarchy on the left.
Oh, okay, that's cool. Okay, so get out of here, stupid thing. Anyway, let's see, which one is this? All right, so this is the student file itself. So what I've done so far, I've matched up these categories. They all line up with the CSV and the order they need to be inputted. Let's see here. How do you make this stupid bar go away?
Which stupid bar?
This Zoom bar.
I think there's a button to collapse it, possibly. It is pretty big and obnoxious though.
Yeah, let's move it to the bottom.
Cool.
Okay, so the runner file, I guess I can just run this and show you. All right, so when I run number 1, I get the normal students here, and then I get my info, and I'm only producing 2 things as far as I can see. John was producing everything, which is odd. And then issue number 2, when we run the second student, if I run 1, 2, 3, 4, 5, if I pick a existing student, it comes up as none, non-existent. If I run my information, it acts like I don't exist, but at least it's reading it from what I can tell.
Okay, so it looks like there's a few things that aren't quite working how you expect them to do. Let's debug these one at a time. Maybe we should just go back up to the first issue you were talking about.
Okay.
Can you show us that again? Just what you're expecting to happen, what actually happens, what's the difference between what you got and what you expected?
Sure. What I would expect to happen is the new line of code that I enter looks like this. At least has all the information, even if the formatting is not the same.
Joe should have the same data as Doug and Dave, etc.
Yeah.
So is Joe on your CSV?
Yes.
So in theory, he should be loaded in the same as all the other students.
So I thought maybe the formatting was screwing this up. So I tried to go in and manually correct the formatting. I matched it to the other students and it didn't matter. So I left it the same. So number 3 works. I can add students.
Is that the same formatting though?
No, right now it's not.
So, I mean, it looks inconsistent. That seems a little out of place to me. So when you're parsing the CSV, what are you using as your separator? You know what I'm saying?
That's a good question. Let's look. That would be in the school file. I honestly don't know. I can't tell.
Because yeah, you know, the C in CSV stands for comma separated values. Typically, that's the default separator between your fields. It looks like you have not specified it here, but there should be a way to pass an option to csv.dictWriter or
could it be because I dictated commas in here and they're back to back?
No. That would just be because, I mean, that's a regular Python list, so it needs to have commas separating the items.
A tab. Somebody said it's a tab, Marcos.
Wait, hold on. So this is where you're writing a new student to your CSV. So Joe wasn't originally in the CSV file, was he? You wrote him in with this code, is that right?
Correct.
So can we see, where's the code where you read the CSV file in the first place?
I'm assuming
So
that
there
would
we're
be
writing it.
runner.
I'd be in person.
That sounds
Do it
about
in
right.
person? Thank you. This is all I have in person right now.
Is the actual data loading maybe happening in your student class? What's in student.py? So yeah,
Okay,
there's
so-
your dict reader. But again, we're not specifying the separator, so it's just going to use the default.
What does the separator look like?
I mean, it should just be like you pass in a comma as a string.
Oh,
Let me just Google this real quick. So yeah, it looks like dict reader takes a keyword argument for delimiter, and then you can
Okay.
pass in a string that says what character is supposed to separate the different fields in your array, or the different fields in your CSV.
okay.
So
what sorry, go ahead.
so let's look at your CSV file again. What is actually separating the different fields? So are those spaces or those tabs in between all your different fields there?
So I think this first one's a space, and then I think the second one's a tab,
That
which is super weird.
probably doesn't help. So do you want to take 10 seconds and just fix this up real quick? Can you just replace all the tabs and spaces with commas instead?
Yeah, sure. Oops.
Joe, I believe that in your console, your name is actually the only one that's properly being displayed, because in the list students, you're supposed to just list the or return the name and student ID. So I think if you add commas, it'll all work properly.
What do you mean?
Well, at least in the README, when you created the list student function, it's only supposed to display the number, the first name of the individual, and then their school ID. So that's why in your console, Joe is returning the correct thing, because it has commas in there already. So if you add commas to these values, I'm assuming that it should they should all display like how number 7 is in your terminal right now.
Oh,
So when I ran your code, that's what I did, is I actually copy pasted the original data, which was comma separated, and it worked.
oh, so somewhere along the lines, we rewrote the CSV and didn't know.
That'll do it. It looks like you got some extra commas in there.
Oh, 1 second. Trying to do this fast.
Yeah, I like the use of multiple cursors. It's a nice little tip, nice little trick.
So as an instructor, do you see that not happening, and in your mind you just go, oh my God?
What do you mean? No, nothing.
Like when a student doesn't use the fast method like that?
No. Multiple cursors are cute, I guess, but there are plenty of other ways to be efficient. I think you were missing some commas in your CSV file before we look away. After Doug88, kind of looks like a username or something.
Oh,
Slayer25, Jesse25. Yeah.
good eyes.
All right, so do you want to try running your code and reading that CSV file? See if you get any better results?
Yes. Okay, not, let's try. Okay, so now at least they're all in sync.
Yeah, they're displaying consistently.
Yeah, so that's good.
I think it's improved. All right, do we want to debug another issue, or have you had enough fun for this morning?
You gotta find them. I don't know where your keys are. Sorry.
Because you mentioned there were, I think,
does that
3 things
achieve
going
what we
wrong.
need? Oh, okay. So we still can't populate a student when we enter their information.
Okay, so what code is responsible for that happening?
That should be wrong. It should be this one, 17 to 20. And then when I go to pull it, it's this guy here.
I believe you entered a student ID that doesn't correspond to any of the students.
Is that the issue?
1, 2, 3, 3, 5 should be Jesse, number 2. Good eyes.
That'll do it.
Let's see if still the same. That was a good eye.
Hey, Joe, you have to quit, hit option 5 and rerun because you didn't kill the program, so you got to start it over again. And I bet it will work this time.
Oh yeah, because you got it running in a loop.
Okay, yeah.
How about
So,
that?
I wonder if fixing the CSV file made it so that it could read these as well then.
It seemed like the source of many of your issues here.
Okay.
So yeah, this has been, I think, kind of an interesting lesson here that really your code was fine, as far as we could see. It was just that the data wasn't right. And then if your data is wrong, the best algorithm in the world isn't going to fix that.
Right. And we said it was delimiter that pulls that information, that comma out, right?
Right. The delimiter is what separates a string, is what breaks it up into parts. So we didn't, in this case, we didn't actually set the delimiter. We just relied on the default behavior. If you don't specify the delimiter, it's just going to assume commas for both reading and writing. So we just changed our data to match the defaults. I think we could have also just set a delimiter of a space or a tab, but that's a little unconventional.
Okay.
So I think what we did was good.
And that piece would go into what I'm looking at right now, correct? The actual code for adding the student, right?
I'm sorry, I'm not sure if I understand you.
Delimiter, if we start messing with delimiter, I want to later, it would go in somewhere within this function here, right?
Yeah, so on line 27, csv.dictWriter, you've already passed in file field names equals whatever. You can also pass in delimiter equals and then whatever character you want. And then that'll be used as the separator in the lines that you write with the dictWriter.
Oh, that's nice. Okay. All right. Well, I'll keep plugging on this because it's not done yet. So thank you.
Cool, cool. You're welcome. So what do we think, class? Is this more fun watching student code, seeing your peers present their solutions, as opposed to just watching me code up an exercise solution? What's more valuable? Yeah.
Yeah, I think it helps to see other people get stuck in similar places that I got stuck.
Okay, I get it. My code's really boring, so I'm not going to make you look at too much of it.
I also think it helps to see the like when a student has an issue and then have the instructor talk them through how to fix the issue. Because whenever like I run into an issue, that's pretty much like what's going to happen. Like you're going to have an instructor or someone come help you fix the issue. Whereas when you just run into your own issue, you kind of already know how to fix it. And it's kind of like a fake issue. So it's not really as like instructive.
So, you know, sometimes I do run into issues that I've seen before and I already know the solution. But honestly, just like you guys, like when I'm working on a, you know, interesting project, I get stumped like every day. I feel stupid like every day and encounter things I don't know and have to look up. I like to think that the difference between a junior engineer and a senior engineer is not that you stop feeling stupid at some point. It's just you start feeling stupid much faster and then you can do other things afterwards. But yeah, I hope that doesn't bother you too much because the feeling doesn't really go away. Let's see, it's 9:45 right now. We've been talking about code for close to an hour. Why don't we take a 15-minute-ish break, 14-minute break, come back at 10, and I'm going to start talking about regular expressions.
Nice.
Sorry about that. We're recording, and let me just share my screen also before I forget. Sorry. Okay. So regular expressions are a powerful, flexible tool for finding patterns in strings. So they have many different uses across various different industries because this is pretty generic, just find a pattern in a string. But as a web developer, there are a few situations where you'll be using them most commonly. So primarily, we're going to be using regular expressions for validating data. So we'll use regular expressions to answer questions like, did the user type in a valid date? You know, maybe we need our dates to be formatted like this. And not like this. So we could write a regular expression that checks the format of the string to determine if, you know, this is the format we want to be storing it in before we actually store it in the database or try to put it on a calendar or something. We might also use regular expressions for password validation. You know, every time you sign up for a website and they're very choosy about what your password can be, they've got all these rules. So oftentimes those password rules are enforced by using regex. So another little fun thing, you can also use regular expressions in your editor to search through your own files. So you might have noticed this little search tab over here. There are different buttons here. You can click for different kinds of searches. This little dot star. I don't know if you can see the tooltip popped up, but this is a regular expression search. So I can type that and then type regular expressions here, and it'll search anything in my files or folders that matches that expression. So it's much more powerful and flexible than just like a plain text search. But we'll see that a little bit later after we've actually learned some regular expression characters, some tools to actually use. So one unfortunate part about regular expressions is that they're really hard to debug. So if we were processing a string over many lines of code, we could debug it line by line in order to understand better what it's doing. But in a regular expression, as we're going to see, there's a whole lot of logic that's contained in a single line of code. So in order to verify that our regular expressions are working the way we want them to, and just for me to communicate my intentions to you while I'm coding up these examples, I'm going to be writing unit tests using Python's built-in unit test module. So there are a few different options for unit testing in Python. The built-in unit test runner is pretty good though, and it's fairly commonly used. So just for simplicity, that's what I'll be using today. So when you're writing tests, you're probably going to end up with a lot of them. Organization is important. So I'm just going to point out this folder structure I'm going to be working with here. Got two folders primarily. A test folder is going to have a bunch of individual files for tests. And then my validators folder is going to have a bunch of individual files that contain validation functions. So there's going to be one test for every validation function. Now, if you've never written a test before in Python, you might just Google Python unit test. You would find this page from the Python docs. I don't feel like doing too much reading right now, so I'm just going to copy and paste this example into my editor, and then we'll see what needs to change from there. Let's make a new file. So for my first validation, I'm going to do some really simple password validation, because so the word password is a pretty terrible password. Someone's trying to crack your account. That's the first thing they're going to guess. So we're just going to write a regular expression that guarantees you have not entered password as your password. So I'm just going to call this test is not password.py. Paste in test code. So first thing I want to point out is that the test name does have to start with the word test. We're going to see why in a second. But in order for these to be treated like test files by the test runner, they have to be named that way. And then inside of the actual test, the first thing we do, well, we import the unit test module. The second thing we do is we create a class that subclasses from the built-in unit test.test case. So commonly, as you're working as an engineer using these big powerful frameworks, honestly, this is how you're going to end up using object-oriented programming a lot of the time. It's not that you have to define all the classes that your program uses and how they relate to each other and whatever. A pretty common situation is that a framework will provide you with some base class that's very powerful, has a lot of methods built into it. And then you're going to just define a subclass that inherits from that base class. So you can get access to all of the methods that are built in to unit test in this unit test.test case class. And then in my subclass, I only have to specify the few things that are specific to my application. So even though there's only 3 functions in here, this class can do a lot of stuff because it's inheriting from the unit test case. One other thing that I want to point out is that these individual test functions, they all start with the word test. That is also required. If you don't prefix them with the word test, then the test runner doesn't see them and it doesn't treat them like test functions. So let's just make a little comment about that. Andrew, you got a question?
Yeah, sorry, what's test case again? So let me see if I get it right. So unit test is the module that we're importing,
Right.
and test case is a pre-made class of unit test case that we're passing through.
Yes.
Okay.
So that's exactly right. Unit test is the module we're importing. This is built into Python, so I didn't have to install it, just need to import it. And one of the features that is included in unit test is this class, unittest.testCase, which has a whole bunch of testing functionality built into it. So we can leverage that in our subclass. Lyman, you have a question?
Yes, so the test string, that the class that you named that's inheriting the unit test case, you can technically name that whatever you wanted.
This?
Yes.
Yeah, this can be whatever I want.
Okay.
So the class name does not actually have to start with test. Basically, everything else here that we name needs to start with test. Okay, so I'm going to open up a terminal, see if I can run this. Right, so I could, if I wanted to, just run this test file individually by naming it on the command line, but I want to give you a little bit more of an authentic look and how tests would work on like a real project. So I'm going to invoke the test runner, and this is going to run everything, every test in my test folder. I'm going to say Python, and now I'm not going to actually invoke my script like, you know, tests like that, whatever. I'm not going to actually invoke the test. New Python -m. -m means use a module. So I'm using unit test. So here we're seeing a second way that it can be used. I already used it importing it into my code, but I can also use that same unit test module from the command line. Saying I want it to automatically discover my tests. I don't want to have to specify each and every one, because that's going to rely on the automatic behavior that I was saying before. If I just name everything correctly, then the unit test should be able to find them. And then I have to tell it which folder contains my tests. They're in the test folder. So then I run that. And then I get this kind of output from the tests. So this is pretty typical test output. I've used a variety of different test frameworks. They pretty much all look like this at the command line. What you're seeing here is one period for every passing test. So let's actually make one of these fail so you can see what that looks like. So here, this is correctly asserting that foo is an uppercase string. Let's just change that to lowercase. So now this assertion is going to be false. So that should throw an error. So now if I have a faulty test, it looks like this. So now in the output, we see an F for the failed tests, and then a period for all the passing tests. And then we actually get an error message for each of our failed tests. So this way, imagine if you had like 1,000 tests that you were running and 998 of them passed, but 2 of them failed. You want an easy way to focus on the error messages from the 2 failures. And you want to make it easy to, you know, not look at the 998 passing tests. You don't want that cluttering up your screen because that's not interesting. It's not what deserves your attention. Andrew, question?
The function like is upper. Is it only built just to test if a string is upper?
I can't imagine what else it does.
Okay. Do a lot of like, are there a lot of methods like that?
More so in Python, I would say. Python has a lot of methods that are built in that they're supposed to just make your life easier. You know, the kinds of questions you could answer by looping over a string and then checking every character and doing some logic. Python might have a single method built in that just does it for you all at once. I'm accustomed to writing JavaScript where you have to kind of do things yourself more. So that's how I think of things. I don't always look for like more automatic methods. Like in JavaScript, you would just convert the string to uppercase and then compare if it is equal to the original string. It doesn't have like a true or false, is this upper method. So I didn't know that this existed in Python, but it's cool. It's a little bit more concise for a slightly different use case. Was there another question? Oh, I saw a hand up. Suruchi?
Raphael, is there a difference between running the file like this and then when we write Python tested.password.py?
The difference is that I want to run all of my tests simultaneously. So right now I've only got one test, so it doesn't seem so special. But throughout this demo, I'll be writing more test files. And every time I run my tests, I'm going to run all of them. So I'm going to be using the test runner to run every file automatically instead of having to specify them one by one.
All right, thank you.
Any other questions? All right, so I think that's enough background about testing. There's certainly a lot more that I could talk about testing, but I think that comes a little bit later in the program when we've got more background, more context for application development. So for now, I'm just going to delete all of this kind of placeholder example code. I'm going to write in an actual test case that should test my validators. There's a couple hands raised.
Okay, I'll just go ahead. I'm just wondering if the unit test content will be on GitHub.
Everything you see me coding here today will be pushed up to GitHub after the lecture.
Okay, thank you.
Is there another question? I swear I saw two hands. Okay, guess not. So yeah, that's as much as I want to really talk about unit testing. This is mostly supposed to be about regex. That's just some background so you can understand what I'm doing here. So let's actually write tests for a validator function. So I'm going to make a validator. It's a new file. We're going to name this similarly to the test for it. Say is not password.py. Okay, so for right now, actually, I'm not going to finish defining the function. We're just going to have an empty function so we can have something to test, and then we'll fill it out later. So in theory, is not password. This is a function that should take a string as input and then return true or false if it is the string password. So this is a pretty basic use case for regular expressions, but I've got to start somewhere. So for right now, I'm actually not even going to finish the function, just going to write pass. This function does nothing. But now I'm going to write some tests for it to clarify what I think this regular expression should be doing. And then I can run the tests after I try writing it to see if it actually works the way I'm expecting it to. So first, I'm going to change the subclass name to something a little bit more meaningful. Call this is not password. So the first test this is going to be kind of an optimistic test. I like to think when I'm testing, there are kind of two different kinds of tests. You first got your optimistic tests, which test that if your function receives valid input, that it responds correctly. And then the flip side of that is you've got pessimistic tests, which is if you give your function invalid input, does it also reject that correctly the way it's expecting it to? It shouldn't accept invalid input as if it were valid. All right, so because we are subclassing from test case, we get access to this assert true method. I didn't define this, it's just on self. Presumably it comes from unit test.test case because it's not defined in my class. I'm not going to think too hard about that for right now. So I'm going to assert that if I call is not password on this string, let me in. So this is not the string password. So that should be true. If this function is written correctly, it'll return true that let me in is not password. And so this will do nothing. That's the point of an assertion. If your assertion is correct, then the statement does nothing. If your assertion is false, then it should throw an error. So the whole point here is to stop our program and throw errors if something is not what we think it should be. Oh, I'm getting some red squigglies here. It looks like I did not import this. So I got to do that. So I've got my validators folder, as this file is not password. I'm just going to import everything from it, including the is not password function. Because my module has a function with the same name as the file. So try not to get tripped up over that. And just to be thorough, I'm going to add another assertion. So the password code word is also not password, so that should be valid. And now I'm also going to make some pessimistic assertions. So when my validator receives invalid input, does it successfully reject the input? So does it return false, or does it return true for, does it return false for is not password when you pass in the string password? Sorry, there's a lot of negation. I'm getting confused. So we'll use self.assert false is not password with the string password. So this should definitely be false because this is the string password. We'll make it a little trickier. Add another test case. Add password in sarcasm case. So this is going to make my regex maybe a little bit trickier. Because I also want to forbid this. I think that this is a bad password because it's still just the word password with mixed case. So I'm going to have to write a regex that forbids that also. So now I'm going to run my tests just to see what it does so far, see what I'm working off of. So we got 1F, 1 dot. So it looks like, where is it? Assert false. Let me in. What is? Oh, right. Because I didn't write the function yet, it doesn't do anything. There's no way these could pass. So this was exactly what I was expecting. Sorry, got ahead of myself a little bit. So I have not written the validator function. It doesn't do anything. I guess it returns none. So that counts as false. So these are mistakenly passing. But the point is now I have not written my function yet, so we shouldn't expect these tests to work. I just wanted to run them, watch them fail. Sorry, there were some hands up a couple minutes ago.
Hey, Raphael.
Hello.
When you imported the file from the validators folder and you just did import asterisk, is that, so you said that imports the entire folder?
The entire file. So validators is the folder, is not password, is just this one file inside of it.
Okay, yeah. Would you recommend just doing that like regularly, or should we stick with just importing the class if that's the only class in that file?
It depends on how you want to write your code. So like sometimes it's nice to not use the star. So that way you have to prefix the things with where you imported them from. So like unit test.test case, we can't just be like test case. You have to say unit test.test case. I actually like that in some cases because it's easier when you're reading the code, it's easier to remember where things came from. You don't have to like scroll back up to the import statements to remember where things were imported from. But it's also just a lot of extra typing. So in this case, for all of my calls to is not password, I would have had to type validator dot or validators that is not password, and would have been kind of repetitive and I thought not very interesting. So I imported the validators like this, so I could just access the function itself instead of accessing the module and then the function inside of it.
Okay, thank you.
Was there another hand up, Bao?
Yes, so just a very quick question. So when you're using the test functions, like the result, there's only two results, a fail and a dot. I mean, I guess it's a pass. So how would you find out if there's like any individual test case that is failed instead of looking at the overall picture? Like, how do you know if there's individual test case failed?
So this doesn't tell me which assertion failed, like doesn't tell me if it's this one or this one, but it does tell me which function failed. So here the failure was in allow anything but password, which is this function. So it's telling us that this one evidently passed, but this one failed. So it's fairly granular. And actually, I'm going to show you one more thing we can do here to make the output even more clear. So ideally, when you're writing a test, there should be some plain English description of what you're expecting to happen and maybe even why. So the way we do that with the unit test module is I'm going to add this triple quote string. All right, so I added those little informational strings. And so now when I run the tests, when the test fails, in addition to printing out the name of the test, it also just prints out my little doc string there. Optimistic assertion, allow anything that doesn't contain password, just whatever English I think is useful to describe the test, I put it right there. So it helps you read the output a little more easily. We have a few more hands go up.
Yeah, I just had a question about how you called it again. I think I missed it when you were explaining. Python-m calls the module, unit test is the module. What does
Yeah.
discover-s do?
Right, so that's part of the unit test command line interface. Because normally you can use unit tests to just run individual tests at the command line or have it do other things as well. But discover is how you get it to find your tests automatically and then run them all in just one call. So like how I was naming everything really deliberately with test at the start of the files and the functions all start with test. When I run unit test with discover, it's basically looking through everything that's in this folder that I name test and trying to find everything that matches that pattern and then running those tests.
Okay, yep, I see it.
Wonder if I. Okay, yeah. So I just kind of guessed that we could get some help for the unit test module. If you're ever using something at the command line, you don't really know what you're doing, just ask for help. So I tried Python -m unit test, and then just -- help. Tells you a little bit about what it can do. Should be some description of the discover feature.
Okay, just to clarify, like the only reason it can run the is not password.py is because you imported it in originally, but your module only runs inside your current test folder. Because you imported it from the other function.
Right. So when I
Yeah.
run the test runner like this, it's not going to find any tests inside of my validators folder if I put them in there for that reason, for some reason, which I shouldn't do. But yeah, it's only looking through the test folder. But because this file has an import statement from the validators folder, it's able to reach into that folder and get the code that it needs. Make sense?
Yep, thank you.
Were there other hands up?
Yeah, I just have a quick question. How is that printing out without like a print line? Is that just a functionality of unit tests?
Yes.
Okay.
That is one of the many things that unit test does for us automatically.
And it has to be, does it have to be triple quotes for that to work?
Yeah, that's a special feature of unit test. Like this should look kind of weird to you because just putting a string in the middle of your code shouldn't do anything normally. I'm not assigning it to a variable or passing it into a function or whatever. This is like basically a comment, except it's not a comment, it's actually a string. So like normally this should look kind of weird to you, but I read the documentation on unit test and this is what they say to do. This is how you add plain English descriptions to your tests. So when I run the test runner with Python -m unit test discover, it's, I guess, doing some clever things before it runs all my tests. And so it's actually like looking for these strings in my files so it knows what to display when the tests fail. Cool. All right. Any other questions before we move on? Jesse, what's up?
Yes, just one question. I was trying to understand it in the documentation as well. The line 18 that you have there.
Yep.
What exactly does that do?
Okay, good question. It's not necessary that you understand this for this lecture, so I didn't want to distract you with it, but since you're asking, might as well explain it. So every time you run a Python file at the command line, just like, you know, Python myfile.py or whatever, there will be defined inside of that file this variable dunder name, and it'll have the value of dunder main, but that's only for the file that you named at the command line. So if I call this file from the command line and then it imports another file, like it imports validators, inside of this file, there will also be a dunder variable called name, but it won't have the value of main. So the idea is that when you have one file that imports another file, that imports another file, et cetera, in this big web of files, sometimes it's important to know programmatically whether a file is running because it was run at the command line or if some other file was importing it. So in the case of unit test, I imagine it makes a big difference if I'm going to run this file just by itself. Like if I just run it from the command line directly, then I'm not using the unit test runner. And so it has to manually call unit test.main in order to run my test. But if I'm running this unit test as part of the unit test runner, then it would no longer be the main module. There's probably some other Python code that's importing it. So in that case, we wouldn't want to run unit test.main for every one of our test cases. It would just be like the first thing that imports all of them probably calls that. Does that make sense?
Yeah, I think that helps quite a bit because I was trying to understand what that meant by the direct code in the documentation. So thanks.
Okay, yeah. Okay, so just clarifying this, you might see this syntax again in other Python files you work in, other tools with Python. Basically just allows the script to do different things if it was invoked at the command line directly, or if some other file tried to invoke it. All right, so now let's actually express some regular expressions here. We've written some tests that do nothing. I've clarified my intentions. This is what I'm trying to achieve here. It should allow us to use let me in or code word. It should not allow us to use either of these two passwords. I'm going to actually write my validator. So first thing I need to do is import the regular expressions module. This is again built into Python. Import re. A lot of the built-in modules have very concise names. So regular expressions just re. So what I'm going to do is I'm going to use the regular expression module you call the match method. Pass in a string. So the regular expression module has actually a lot of different functionality. The most basic thing that we'll need to do is just match. It'll just tell you pretty much yes or no. Whatchamacallit, if a certain string matches if a certain string, input string matches a regular expression pattern. So our function is getting input passed in, and we're seeing if there's a match between the input string and password. So this just looks like a regular string here, but this is actually a regular expression. So the simplest regular expression I could imagine, where it's just matching on literal characters. So we're starting pretty basic, but the letters PASSWORD should match, those exact letters. These aren't magic characters yet. We'll see that in a second. But just know that, we can also do simple stuff with regular expressions. So that's going to return us a match. This isn't actually a Boolean. It's going to be true. It's going to be an object that describes the match. So if I didn't know too much about this, I would look through the Python docs. Here's regular expression.match, describes what it does. So it's telling me that if the string does not match, it's going to return none. So that's a falsy value. And if it does match, it returns this match object. Now, I don't know what that looks like, but there's a hyperlink here. So if I click through that, is this not that next page? Match object. Okay, so yeah, I guess it was further down the page. So if I click on the hyperlink, it takes me further down the docs where it describes what the match object does. And it has its own methods that can tell you more about what you matched, like, if it matched multiple times or if there were different parts of the match. But this is much more advanced than I care about. For really the rest of this lecture, and honestly for like most of my career, all I'm going to care about is just yes or no, does it match? So is this an object or is this none? That's all I care about. So what we're going to do then is A quick little ternary here in Python. So if there is a match, so the password that they type in for the input matches password, will return false because it's not true that it is not password. Otherwise, we'll return true because if there's no match object, then it's true that what they typed in was not the literal string password. Okay, so now we're getting some different failures. Actually, let me put this in split view so you can see my tests and the validators at the same time. That seems like it'll make this a lot easier. Sorry, my editor is split up into 4 windows here. I hope this doesn't get too cramped, but we should be able to see all the important stuff. Wait, no, this is the validator on both sides. Hang on. Okay, there we go. Sorry about that. Okay, so looking at the test output, the first test passed. So our optimistic assertions, these are all good. And then we got an F for our pessimistic assertions. So the first function actually was fine, but we can see here the actual assertion that failed is self.assert false is not password for the mixed case password. So now these unit tests are kind of helping me understand how my code is working, how it's not working, what I might need to do to fix it. So let me open this up to the class. We're gonna have a quick pop quiz. What do we think I should do to change my regex here in order to make it match this other case? You have a question, Nathan?
Yeah, I do have a quick question. I just want to make sure I'm following. So you have it by default returning false if the match is correct. So when you assert it as true, even though it's not, the input's not matching, it's returning as true. For the first test cases, tests allow anything but password. Because assert true is passing those as true, correct?
Right. So is not
because
password.
And that's because the function's returning false. Right?
Here it should be returning true. Because let me in is not password. That's true. I'm trying to define the functions so you can sort of read them like English.
Okay, so assert true is failing. No, those are passing.
Right.
Because the input does not match and the function is by default returning false.
Returns false. Wait, sorry, the negation is really confusing me. Yeah, it turns false if there is a match.
Okay, so it returns false if there is a match.
Right. Because
okay,
so the regex itself is checking that it is password, but the function itself is checking that it's not password. So the function itself has to return basically the opposite result of the match. So if we do find a match, we return false. If we don't find the match, we return true. Sorry, the negation is a little bit mind-bending.
Got it. Okay, thank you.
The other ones will have more complex regex, but they might be easier to read and talk about. Jesse?
Back to the question you're saying, how can we pass if it's lowercase and all that? Wouldn't we need to do a flag?
That's one option. I haven't really taught you anything about regex yet, though, so I'm not expecting you to
No.
know that quite yet. There might be other solutions we can think of. There's 2 hands up. I can't see who it is. Rob?
Is it the case I, like insensitive?
That would probably work. I'm not exactly sure the syntax using the regex module here, where that would go. I was gonna show you a different solution. For now, I'm gonna show you kind of a cheater solution, and then we'll come back to this later in this lecture and figure out a better way to do this, or another way that lets me show you different regex syntax. So one solution using techniques that you already know, I'm just gonna convert the input to lowercase and then compare that against my regex here. So then it shouldn't matter what the case is for their actual typed in input password. We're gonna lowercase that and then compare that to our literal regex string. Okay, so cool. Now all the tests are passing. So by lowercasing that, it now passes the regex. It's acknowledging that this password is password, so it's returning false. So that's what I was expecting. Let's ask some questions. I know I'm saving all the interesting stuff, but I just want to make sure that we're solid on these basic things before we start introducing meta characters and stuff. No questions? Okay. So now where regex really gets fun, of course, is not just being able to match literal strings, because you already knew how to do that. You didn't need regex to do that. Where things get interesting is with, sometimes they call them like operators or meta characters, I've heard. I'm just here on the Python docs where they explain this pretty well. Also, Mozilla Developer Network has some pretty good documentation on this. So let me see, for one example, dot. So the period is a meta character in a regex that matches any single character. So right now I've just been matching literal words, just the string password, but I can use a period to instead match any letter at all. So let's go to a slightly different example. So I'm going to make another validator file, and I'm going to make another test file. So I'll just copy the ones that I've got. Okay, so just as a jumping off point to avoid typing all this out by hand, I copied the previous tests that I wrote, and I'm going to make some modifications. You can see by the file names that I've chosen that for this next test, we're going to make sure that a password is at least 12 characters. So it's really important when people sign up for your website that they choose a secure password so you don't get hacked and lose all of your user data. So we're going to insist for our website that all users have at least 12 characters in their password. Got is at least 12 characters. And test is at least 12 characters. All right, so first things first, I gotta change the name of this function. I'll delete that, just make it pass. And over in my test file, got to rename the class that I'm subclassing. These all have to be unique. Call it it's at least 12 characters. So we got our optimistic test here. That should be able to successfully allow passwords that are at least 12 characters long. And then pessimistic tests under so we forbid short passwords. All right, so now let's change what these assertions are. I also have to change what we're importing. So I'm not using is not password. We're using is at least 12 characters. So I'm going to test a couple of long passwords here. Correct horse battery staple and dragon princess. So these are pretty long passwords. They're longer than 12 characters. They're also both terrible passwords for other reasons, but we're not going to get into that right now. I mean, they're just both very common passwords, so don't use these for anything. So we need to test that these are allowable passwords. And then gonna have some pessimistic assertions. So if someone tries to sign up with the password brevity, that's too short. And then a special case that I want to make sure is handled is empty string. This is definitely too short, but it's just kind of a special situation. I want to make sure we're handling it. Oh my gosh, I'm so sorry. I definitely just typed the wrong command. Can I? Okay, looks like I can actually get that back. Sorry, I accidentally repeated the copy command and then just overwrote my test file. Looks like I was able to undo, so we're good. All right, so I ran the test and I'm getting a failure, just like I'm expecting because I've not actually written the code yet. So I think now is a good time to take a break. let's take a 10-minute break, 11-minute break, come back at 11:05. And while you're all on break, I want you to think about what regular expression we need here. What regular expression would match a password that is at least 12 characters long. Hint, it's going to be using things that I've already mentioned in this lecture. Or actually, before we break, does anyone have any last minute questions? No questions before the break? Okay, great. I'll see y'all in 10 minutes. Hello, class. Welcome back. So I hope you've had a good long time to think about this quick little regex challenge here. So now, who can tell me if I want to write a regular expression here in my validator file, is at least 12 characters. What should that regular expression look like so that these strings match it, these long ones, and these short ones don't? Any ideas? Andrew?
Bunch of dots.
It is going to be a bunch of dots. How many dots do you think I need?
It's got to be at least 12.
Right. So this is a pretty loose password restriction. It just needs to be 12 characters, any characters. Each of these periods is an individual meta character in regex that can match any other character, letter, number, white space even. So now if I run this, oh, right. So functions also need to return values. That's an important part of writing functions. So we search for a match. If there is a match, we return true, meaning the password, the input is at least 12 characters. If there is no match, we get none, then we just return false. So let's run these tests again. Okay, great. So this time everything passed. Everything is working out the way I expect it to. So that's how the period works in regex. It's probably the simplest meta character, but it's pretty useful. So I'm going to move on to the next validator. I'm just going to show off some more regex syntax. But if anyone's got any questions, we can take a minute.
I had a question, Raphael.
Please.
Are meta characters standardized across languages for regex?
Mostly. So this is a little bit unfortunate, but there is some variation in regex between different languages, different implementations of regex. I want to say it's like 99% the same. And honestly, I don't get deep enough into regex where I've experienced any differences between one implementation and another. Like everything I've learned about regex works everywhere that I've tried to use it. I know a phrase I've heard in the past is Perl compatible regular expressions. So there's another programming language, Perl, which apparently is famous for people using regular expressions in it to do all kinds of wacky things. And Perl actually supports more like sophisticated versions of regular expressions, I guess, than other programming languages. So if your programming language is also like just as good and sophisticated handling regex as Perl, sometimes they call that Perl compatible regular expressions, or PCRE. So that's like kind of a slightly better form of regular expression. I wouldn't worry about that too much. Just know that there are some slight differences, but hopefully they won't come up for you. I saw another hand up. No? Okay.
Yeah, Raphael, I was wondering, on your line 7, when you're returning, I know that when you do those conditional statements, you put a colon, but here in this case, like, there's none of that there. I just wondering if you could clear that up for me.
So in a traditional if else statement, there would be a colon. I'd say if match turn true, else return false. So yeah, in a traditional if else statement, you would use the colons. It's because that I'm using this ternary syntax where I'm doing it in one line, excuse me, that you don't need that.
Thank you.
Yeah, so those are equivalent. Good question. Jesse?
Yeah, I had one question, and you probably already said it. I just probably didn't hear it. The input that was supposed to be character, how do we know if it's being matched if we're not actually writing an input to match it to that?
Say again?
So in the line 6, re.match, and we have those 12 characters, and we are comparing it against the input. Where is the input that we're writing?
Yep. So in the test cases, that's what's getting passed in over here. I'm calling the function is at least 12 characters, and we're passing in correct horse battery staple. And so that's going to serve as our input when the function gets called.
Okay, perfect. Thank you.
Cool. All right, so think here. So I'm going to create Bao, do you have a question?
Yeah, I'm sorry. Just before we move on, I just want to make sure I didn't get it wrong. So for the assert false, is it supposed to be like that? The output from the function is supposed to be false. That way, the test case will return true.
Right.
Okay, because I think I was confused about it for some reason. Thank you.
Where is that? So yeah, assert true. This is saying that what we're expecting this to be. So this function had better return true, or else this line of code is going to throw an error. All right, so next validation requirement we're going to work on is checking that something is alphanumeric, that is has only letters and numbers. So this might be a requirement for a username for a website that you sign up for. You can choose almost anything, but it needs to be kind of human readable. You should be able to pronounce it like it's a name. You should be able to address someone by their username. So it shouldn't be just like all punctuation marks and stuff. So we're going to make another validator that checks that the input string is alphanumeric. It's only letters and numbers. Got our test is alphanumeric. I'll make my validator. All right, so in the interest of time, I'm actually just gonna copy and paste the test cases for is alphanumeric. So you don't have to just watch me typing these all up. You've seen me go through the process a couple times now. So the only error right now is it's complaining about the import for is alphanumeric because I have not defined that. So I'll do that here. All right, so now my editor stopped freaking out. This is a valid import after I've defined this here, but that's not a valid function. Okay, pass with 2 S's. So before I actually write any code, I'm just going to run the tests Oh, it didn't save that. Okay, there we go. So now we're getting some failures on is alphanumeric, which makes sense because I didn't actually write any validator code for it. So usernames like 7-Eleven should be legitimate. We should allow that. We want to also allow dashes or underscores, I guess I should say. And then some other requirements, though, is I don't want any username to start with a number or an underscore. So it can contain a number and underscore, but it can't start with it. So let's see if we can get any of these test cases to pass. So I'm going to show you a new feature, new regex feature, a meta character \W. So this matches any word character. So that could be a letter, a number, I think even underscores or dashes. So I think that actually describes all of the things that I want to be allowed. So that should be fine. Now, the next meta character that I want to show you is plus. So the plus means repeat the previous thing one or more times. So this should match strings that have any number of word characters, but not like punctuation marks. Oh, got to import regular expressions. And now we run the code, run the test, see what happens. Okay, so it's getting past our optimistic assertions. So these are all working correctly. It successfully accepts 7-Eleven as alphanumeric. And it also accepts a username with 4 dashes. I'll just change this. It also accepts that. But now we're getting some problems because it's also accepting things that it shouldn't accept. So our pessimistic assertions are failing. It's accepting Tupac as a valid username when it starts with a number. So I don't want that. So it means that I need to update my regular expression here. So what I've got here is partially correct. For most of the username string, will allow any word character. It's just for the very first letter that I want it to be even more restrictive. So I'm going to use 2 more regex features here. The brackets in regex is kind of like an or expression. It means choose one of the things inside of these brackets. And then also I'm going to use a dash, which creates a range. So if I say A to Z, this means match any one letter from A to Z. Now, similarly, we can do a range from capital A to capital Z. So this is a pretty common regex I've seen in a lot of different situations. A to Z, capital A to Z, basically just means any letter. capital or lowercase, any single letter at least. So here, this is defining just the first letter of our string. Needs to be any any alphabet character. And then after that first letter, we can use any word character for our string. Now there's one little problem here. Things are going to get a little tricky for us, because this meta character here uses the backslash. And so we might remember that in Python, the backslash in strings sometimes has special meanings. Sometimes like \n is a new line, \t is a tab character. There are other escape sequences that start with a backslash. So when we're writing regular expressions, that might get in our way a lot. So thankfully, Python provides a solution for that. It's pretty simple. So kind of similarly to how we had F strings before, you just type F and then a string, and it kind of works a little bit differently from your regular strings. In Python, we have R strings, where you type the letter R, and then you write your string afterwards. And then inside that string, though, backslashes cannot be escaped. So they have no special meaning. So Python is not going to do anything special with this backslash here because it's in an R string. Instead, it's going to be interpreted just as a regex character. Jin, did you have your hand up?
Oh, yes, I was just gonna ask if you could repeat what the plus stood for again.
The plus means one or more of the previous thing. So right here, the \w, this is one character essentially in regex. This is one meta character, means any word character. And then the plus just means one or more of those. So after the first letter of our string, we'll have any number of word characters. So this could be numbers or underscores, but this one is more specific. This is just letters A through Z. And again, I run the tests. And so now it looks like I'm getting the output I wanted by making these changes to my regex. I'm now passing all the tests. It's rejecting things that it should and accepting things that it should. So this is probably the first really interesting complex example where we're using a bunch of meta characters together. People need a second to digest that or have any questions before we move on. Rod?
Just real quick, making sure the brackets are checking the first character in the string, right?
Right. Because everything in the brackets, it only matches one character because it's like an or expression. There might be multiple letters inside of it, but you're saying I'm looking for exactly one of these in the string. So in this case, it's only going to be the first character. I could have done something like this. And so then that would be like, look for one or more letters and then look for this afterwards. But since I want to look for exactly one letter at the start, I'm not going to do that. I'll just leave it like that.
Thanks.
Mm-hmm.
Raphael, I just have a question out of curiosity.
Yep.
Different languages, are there built-in converters to transfer regex over to different languages? Like if we were checking letters for Spanish or Arabic or Chinese?
Oh, you're saying if I want to check for these, or just non-alphanumeric, non-Latin characters, or
yeah, just something like that. Because I know that you can do it like, I guess you would have to use an approach that uses more like the what's it called, like the ASCII code of the thing.
Yeah, I was reading about this the other day. There is some way that you can specify, I believe, like other character sets in a range. So not just A through Z, but other sets of characters too. I don't know offhand how to do that. It's definitely the fact that English speakers are privileged in the programming world. So there are definitely some other complications if you're programming in a foreign language. Does that help? Do we have other questions? No? Okay, let's move on. So the next validator I'm going to write is detecting repeats in a password. Because, you know, for a secure password, it shouldn't be just like one word repeated over and over, like bang, 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 or whatever. Because in theory, that should be easier to crack than if it was, you know, a whole bunch of different words in your password. So we're going to write a regex that detects repeats. So we're going to make a new test file. Does not repeat. We're going to make a validator for it. We have a question, Joseph.
I was gonna ask, is what Andrew was talking about called casefold? I don't really understand how casefold works. So I was hoping you might go over that in today's thing anyway, but yeah, I think that's what Andrew's talking about.
I'm not familiar with casefold. This?
Yep, that's it.
Huh. Yeah, this seems similar to lowercase, but then they're talking about German letters. I've never used this before, so I'm not exactly sure what the use case is. I'm sorry.
Okay, thanks.
Definitely always good to be, you know, thinking about things and making comparisons, but unfortunately I don't have anything useful to say on that. Okay, so we're testing for repetitions. Grab my assertions over here. So I want to make sure that there are no repetitions in your password. So these passwords here should all be good. They don't have any repeated letters in them. For this third one, I made the decision that I'm only going to forbid repetitions with 4 or more letters. If it's only 3 letters that are repeated, I figured it was a little bit too easy to accidentally flag a password. So if it has at least 4 letters that repeat in a row, we'll call that an illegal repetition. So red, 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 that should be allowed, but ding, 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 we're not going to allow that because it's a 4-letter word that's being repeated. And then also deal or no deal should not be accepted. Even though there are other letters in between the repeated words, there's still the word deal that gets repeated at the beginning and the end. And so we want to be able to catch that. So now I'm going to write my validator. Import regular expressions. Going to use another R string here.
It's not saved as a PI file, yeah.
Sorry, the Zoom UI is covering up the file names, so didn't see that. What the heck? Okay, does not repeat. And then like before, okay, yeah, I already talked about my assertions. So in order to check for repeats, we need some way to kind of, save one part of the match and then compare it to another part of the match. So in regex, there's this feature called capture groups, where if you use parentheses in a regex, anything that gets matched inside those parentheses, you can refer to it later in the regex. So put here in parentheses, ... So I was saying before, we want to forbid repeating words that are at least 4 letters long. So we're going to check at least at the start if there is a 4-letter sequence, but then we put it in parentheses so we can save it. And then what I'm going to do is I'll refer to it again with \1. So this is how I refer to the first capture group in my regular expression. If I had multiple capture groups, like that also, then I could refer to that one with \2, but we're not going to do that today. We're going to keep it a little bit simpler. So this should check that there is a 4-character string in our string, and then that exact 4 characters gets repeated later on. So let's run our tests.
There's no input in the match.
Yep, so that's definitely going to be a problem. You need something to match against. So I'm going to pass my input in there. And we're going to try running these tests again. Okay, cool. That time we only got 1 failure. So let's see what's passing and what's failing. So it looks like the optimistic tests all passed. So it didn't detect any repetitions in these 2 passwords, which is exactly what I was expecting. A little more worried about this one, but we also did not detect any repetitions there because we're only looking for 4-character strings instead of 3-character strings. If I took out one of those periods and I tried running the tests again, see, now we get 2 failures. And it's telling us that that optimistic assertion failed, allowing a password without repeated substrings greater than 4 characters. Yeah, and so it tells us here that failed on red, red, red. So I'm going to fix this logic again. Repetitions only count if they're 4 characters or more. Cool. So we're almost there. But the problem is that one of our cases is not passing. When we call does not repeat with deal or no deal, this is returning true that it does not repeat. But to my eyes, it looks like it does repeat. So what do we think is wrong with my regular expression here? And how do we think I can fix it so that it matches here? or how it be, so that it behaves the way I want it to. Andrew?
It only checks if like the thing is right afterwards. It doesn't leave any room for like space in between the checks.
Yeah, it looks like that's the problem. So what do you think is the solution?
Sort of like dot and then the plus to be like, it's got to be a dot, then the plus checks can be like any amount of space in between it.
Okay, let's see what that does for us. And it looks like that worked. I'm gonna change one of these test cases up a little bit. Say instead of 3 dings, we just have 2 dings. Okay, but now we're failing again on that ding ding case. Jesse, why do you think this is happening?
That's happening because the plus is saying it's 1 and more. We should change it to a question mark, and that'll give it where it could be there or not.
Okay. So
Where to change the plus sign to a question mark.
all right, so I think we're getting at what the issue is here. This dot plus here requires at least 1 of anything. But in this case, there's nothing in between it. So you said dot question mark?
Yes, but also, this is not, I have no clue if that's also going to account, is this in the beginning of the string, end of the string? Do I also want to do anything like a dot question mark in the beginning of that parentheses as well?
This should be good.
Okay.
Re.match should only match the beginning of the string, I believe.
Oh.
So we're still getting a different failure though. So that's interesting. We're getting different test cases to fail here. Playing a little whack-a-mole. So now it's the deal or no deal case that is failing. Any thoughts on why that might be? Andrew?
I just did a quick Google. It seems like the question mark only matches 0 or 1 occurrences. So maybe dot, it's got to be like dot plus question mark or dot question mark plus or something like that.
So it sounds like you all figured out the problem. I could have sworn you've seen this syntax before today, but I haven't introduced it formally yet. So I'll just tell you. So the issue we're having here is dot plus is 1 or more characters. Dot question mark is 0 or 1 characters. But what we want is star, which is 0 or more characters. So the dot, the thing before the star might not exist at all. That's fine. Or you might have a whole bunch of it. So the star in regex is kind of a combination of the plus and the question mark. And honestly, these 3 are probably the things that I use most often in regex. So yeah, that's what we got to do here. So now this is going to check for 4 characters at the beginning of the string. Any number of other characters. And then if we get a repetition of the characters at the beginning of the string, that 4 characters that we matched. Ivan?
So would that match only match characters that are 4, or would that actually get like, if it's like 6-letter word that's repeated? Like if it's 6 letters, since you only put 4 dots, would that still count?
Should.
Or would that only catch 4?
So here I'm testing deals or no deals. So we got a 5-letter word. Looks like the tests run just the same. So yeah, it's it does match, but I wouldn't say it finds that the word deals is the same as the word deals. It's still just going to find that deal is the same as deal. Like once it finds the first 4 letters, it stops searching. So the S isn't part of the match. Was there another hand up?
I just had a question about Ivan's question. So like for like a 6-letter thing with 4 dots, wouldn't it could technically match 3 times then, right? The first 4, the next 4, and then the next 4.
Right. And so that was kind of what I was telling you before about how this match object has a bunch of methods on it. So sometimes like there might be multiple ways that your regex can match a string. So I believe that this match object has some methods in it that can tell you like how many matches there were and where they were in the string and stuff like that. But again, I haven't usually had to worry about that too much. Generally, all I care about is, was there no match or was there a match? Good questions though. Yeah, so it looks like we got the test passing. So I've written this regular expression correctly. So that's cool. I've got one more test case for you all. So for our last test of regular expressions, we're going to validate a social security number. All right, get a little copy pasting for my test cases. All right, so here's how I'm going to try to validate an SSN. There's 2 forms I'll allow it. Either you pass in all the numbers without any dashes, or you format it with dashes like this. So I don't want to accept any other forms, but these are probably the 2 most popular ways that people will type in their social security number. It's clear enough that it is a social security number, like it's not a phone number or a credit card number. I'm pretty sure you can tell just by the number of digits here. So here in my pessimistic assertions, I want to reject phone numbers and also anything that is just plainly not a social security number. Okay, so I'm going to show you another meta character here. Excuse me. So similarly to how the \W was for any word character, which was a pretty broad definition we saw. That was, letters, numbers, underscores, all kinds of stuff. I'm going to show you here, \D is a digit. So it's very useful for matching numbers. Now, if you want to repeat something a certain number of times, you can use braces and then put a number in. So this means repeat the previous character 3 times. So then D3 matches 3 digits. So that's how I would match 3 digits. So does anyone have any ideas now? I mean, help me out. How do we fill this out? How do we match the other patterns of digits? How do we match the dashes that may or may not exist? Does anybody have any thoughts? John, what do you think?
So you said that the dash was optional, so put dash and then a question mark for 0, 1, then another backslash D. Capture for 2 digits.
Yep.
And again for the dash question mark.
Mm-hmm.
And then the last capture group is 4 decimals. So /D bracket 4.
Okay. That looks like a regular expression. So let's run the tests and see how it does. Sorry, was there a question?
The input.
Oh my gosh, how do I keep doing this? So yeah, you have to pass your input in so that there's something to compare the regular expression against. Thank you. So we got some errors here, a couple failures.
Is it because you don't have the \D before the 4?
That helps. Let's try this again. Okay, there we go. So now my tests are passing. I'm able to, accept people's social security number, no matter what format they write it in. I want to expand upon this a little bit more. So this does capture like the common situations, like the 2 most common ways someone will write their social security number is either with no dashes or with 2 dashes. What if someone writes their social security number with only 1 dash though? So we're gonna assert false. So let's say I don't want to accept this. I just think that this looks weird and they probably were looking at something that's not their social security card when they're typing this in. So I want to only accept SSNs with 2 dashes or 0 dashes. Using the tools that you've already learned in today's lecture, how do we think that we might accomplish that?
You can do a capture group with an OR.
Tell me more.
So for the decimal or the mid part for between the 2 dashes, you could have a capture group. So parentheses, one with dashes and one without.
I'm sorry, where is that starting? Like here?
Yes. So start your capture group.
So we capture that, okay.
Well, no, you capture the entire, all the way to the end of the dash.
Here?
Yes. And before that last parentheses, put in a pipe. Before, not after.
Oh, you said before the, okay.
Before the last parentheses, do a pipe, and then you can do just dash or slash decimal 2.
Yeah.
And then you would take out the question marks on the 2 dashes because it's either going to have both or 1 or none.
Yeah, that's not the solution I was thinking of, but this works just as well, I think. So, well, I guess you cheated a little bit because you used something that I did not show you today. So this pipe character, this is an OR in a regular expression. So whatever we've specified in this capture group here, we're actually only going to match one of them. It'll only match either this guy, the 2 digits, or it'll match this guy. the 2 digits without the dashes. Sorry, that took me a second to parse. So let's see what that does. Okay, cool. So it looks like that also, that works. All of our test cases are passing. So that's a great regex, working as intended. Just for funsies, I want to show you what the solution I had in mind. So what I was going to do is capture just this first dash here that may or may not exist. And then for the second dash, we just use a capture group. We just refer to the thing that we captured previously. So whatever we capture here, it's either going to grab a dash or an empty string, so nothing. And so then whatever we found the first time, we put it back in again, either another dash or another nothing.
So like you would use that for like, I don't know, VIN numbers where you just, instead of having to constantly put the dash, you just put like one, capture one, capture one, capture one.
Yeah, if you're not sure if the dashes are going to be there or not. Like honestly, if you're gonna build an app where people are typing in VIN numbers, you could just insist that they type them in perfectly correctly to begin with. But if you want to allow your users to be sloppy, then regex is one way you can do that. You can write something like this to accept it either with all the dashes in the right places or with none of the dashes or some combination like that. Does that make sense? Kind of, okay. Bao, did you have your hand up?
Yes. So why did you put the \1? Like why didn't you put it right after the parenthesis with a question mark in it instead of you put like all the way back?
Because remember, in a social security number, there's going to be 2 dashes, and they're on either side of the 2 digits. So we've got the pattern of 3 digits, 2 digits, 4 digits. The dashes are on either side of the 2 digits, if there are dashes. So in the middle here, this is where we've got the 2 digits in the middle. And so on the left side of our 2 digits, there may or may not be a dash. But if there was a dash, then we put it after those 2 digits as well.
So basically you can use that \1 to represent the dash mark.
Yes.
Is that what it is? Okay. And if there's like another object that you're trying to look for, you can use \2 to represent another object you're trying to replace.
Yeah. So right now I've only got one capture group. There's only one set of parentheses. But if I was capturing another thing potentially, I don't know, underscore, question mark may or may not exist, then I could use a \2 to refer back to that.
Okay, thank you.
Yep. Great. Any other questions? Any questions about anything we've seen today, either regular expressions or testing? Marcus?
Yeah, I just got a quick question. So you could refer to that \1 multiple times then right there?
Yeah, I mean.
Okay.
So like
Thank
if
you.
I wanted to test if a string is repeated 3 times, so like if your password repeats it twice, like that's not too bad, but if it repeats it 3 times, like then that's what makes it an illegal password, then I could just refer to the same capture group multiple times.
In Python regex, is there flags? Are we gonna, or are we like gonna go over that and just kind of jumping the gun on that?
No, there are. I haven't really needed them yet. I know in JavaScript, for some reason, there's some differences in some default behavior, and I ended up using flags all the time in JavaScript regular expressions, but been able to get this far without worrying about them. So yeah, there are some flags you can add that make your regular expression behave in different ways aside from the actual text of the regex. So yeah, someone was mentioning before, there's an I flag to do a case insensitive match. So this would probably be a better solution than what I had done before with just the to lower. Looks like you can like change the behavior of the dot character in case that's kind of ambiguous. So yeah, there's some options to make regex behave a little bit differently, but you can get pretty far without them. And I guess I didn't need any of these today. Yeah, good question. Probably a good thing to explore. Always good to read the documentation. We've got 2 hands up.
Okay. Your \1 is the exact same thing as your dash question mark.
I mean, kind of like it refers to it. Like it's different than if I just wrote it twice. You know?
Yes. So your \1 refers, if you did a \1 refers to the first one now, and if you did a \2 refers to the second one.
Oh, well, yeah, right now, if I was going to write \1, \2, these could be different things. Because like for this first capture group, this is either going to be a dash or an empty string, because we've got the question mark matches 1 or 0 times. The second one is going to be a dash or an empty string. So it's possible that the first one is a dash and the second one is an empty string, or vice versa. Was there another hand up?
So when you're doing the capture on the dash, if we're trying to do other capture groups, say like for the phone number, we want to capture the area code and then the 3 digits and the 4 digits, how would that apply with I guess it would be conditional dash being there or not?
I think so. I'm not 100% sure if I understood your question.
Well, basically the optional capture for the dash, how would that work with, like, if you were trying to do a phone number instead, or like with your social, the first 3, you're trying to capture 3 groups, the first 3 numbers, the second 2, and then the last 4.
Well, why are we capturing them though? Like, do we have to refer to them later in the regex?
Well, say we wanted to, do a replacement function or something else. Instead of doing a match, we're doing a search for regex.
Okay. So let's see, where was that? Or I didn't actually write a phone number regex, did I? So let's see, you should be able to do something. Like that. So the first 3 digits are in a group, dash is in its own group. These digits are in their own group. This would be in its own group. And so now, if I want to like potentially allow dashes or not, so now then this is the second capture group, my dash question mark. So I'm going to change that to \2 in order to preserve the functionality I had before of allowing 2 dashes or 0 dashes, but not 1 dash. But also now we're capturing each group of numbers, first 3, the middle 2, and then the last 4 in their own capture group. And so we could refer to them later on with, \1, 3 or 4.
Thank you.
Yep.
I got a question. So going back to one of the first assignments, the balance parentheses, is there any way you could have used regex to kind of solve that problem, since you're kind of capturing and then like, all right, it matches one one opening parentheses. All right, find the closing, or like I don't know. Is there any way you could have solved that with regex, or was that kind of like a impossible task?
I want to say that you can, but I don't think it'll be pretty. I'm sorry, what was the use case again?
Balance parentheses.
Regex for balance parentheses. So yeah, it looks like you can do it. I can't read this. This looks basically illegible to me. Oh, apparently if you're using Perl compatible regular expressions, which I guess is more powerful than .NET regex, there's some extra syntax that makes it more concise even. But so yeah, apparently it's possible. I have no idea how to read this or debug it. This is kind of what testing is really good for. If you needed to determine in your application if some parentheses are balanced, it might be hard for you to write that regex on your own, but at the very least, you could just copy paste this from Stack Overflow and then write a whole bunch of tests for it to guarantee that it actually does, what you think it does. It does what this person on the internet says it does, and you're not just trusting strangers blindly. Let's see, for a related question, because you did ask a really good question. Before you just start blindly like trying to solve a string matching problem with regex, you should ask yourself first, can this problem be solved by regex? Because it's good for simple situations, but for more complex problems, you can't use regex. So a really classic example of this is the question, can I use regular expressions to parse HTML? Just like given a string of text, tell me yes or no, is this a valid HTML document? And apparently, I don't understand all the details of this, but this is a complex enough question, or HTML is complex enough that you cannot successfully parse it with regex. Apparently, this person here is very passionate about that fact and has written up this very long, slightly insane response to this question, basically just explaining a million times over that you cannot parse HTML with regex, and if you try doing so, you'll just go crazy and hate yourself. I really love this. You don't see moderators notes like this on Stack Overflow very often, but this is kind of a historic question. So they wanted to let you know that it's actually supposed to be the way it is, and please don't report it or try changing it. So my point is that regex is powerful, but it cannot do absolutely everything. If you're trying to do something that it seems like maybe people have tried before, like, regex for balanced parentheses, just try Googling it, and maybe someone will tell you like this is impossible, or there's a better tool for this, or here's a regex that solves your problem perfectly. Also, one other fun little tidbit I want to share with you before we leave. So many of you have been probably using some online regex tools. So you don't have to just compare regular expressions in your editor. There's some online tools where you can paste in a string, paste in a regular expression, and it'll tell you where it matches. Those are kind of cool. What I think is a little bit more useful is a random text generator from a regex. These aren't quite as popular, but there's a few of them on the internet. I just found this one randomly last night. So this works in kind of the opposite way, where you paste in a regular expression, and then it'll randomly generate examples of that regular expression. So I'm saying, like, with this regex, I'm just trying to ban any repetition. And so this is just generating a whole bunch of strings that don't have any repetitions in them. I guess if I use a more specific regex, I could get more interesting output. So here, I'm going to use the alphanumeric regex. So it's got to start with a letter, lowercase or uppercase, and then has any number of other characters after that. So we can see all these start with letters. Some are very short, some are very long. Some of them have underscores and numbers, but never at the start. So these are just all random strings that match this regular expression. So if I'm trying to think like, I want this regular expression to only match alphanumeric strings. Like, what are those going to look like? I might just generate some random output from here and be like, yeah, these all look like valid passwords for my website. I would be okay if someone signed up with any of these, or I mean, as a username. I would be okay if someone signed up with any of these as a username for my website. So I think it's kind of a useful way to approach regex. Not everybody thinks about. Okay, so that's actually everything that I have to share with you today. Any last questions before we break for lunch? Going once, going twice. All right. So thank you very much, everybody. Hope you all enjoyed this introduction to regular expressions. You should have some exercises to work on for this afternoon. I don't believe we have anything scheduled for you. So just let me double check the calendar. I'm sorry.
Pair programming.
There is pair programming today. Yeah, okay, so nothing else on the calendar for this evening. We're gonna do pair programming this afternoon. I will Slack out your pairs at some point during lunch. Then the regular evening TA support is gonna happen at 5:30. Yeah, that's all I got for you. Enjoy your lunch, enjoy your day. Take care, everybody.